Hey everybody! In this video we are going to talk about the idea of slope. Okay, so slope is a way of measuring the steepness of a line. Okay, so this is one important characteristic of a line. If you think about it, you only need two ingredients to tell where a line, what a line is doing. You need a point that it's going through, and then you need to know its steepness. If you know those two things, you know exactly what line you're dealing with. All right, so let's talk about slope. Let's go down to some examples here. So here we have a line, and it is and let's see if we can say some things about how steep it is. Okay. Well, if I was imagining that this was some ramp that I was walking up, and I wanted to describe to somebody how steep it is, I might say something like this. I might say that, for every 3 feet I walked in this direction, let's use a different color. For every 3 feet I walked in this direction, let's use a different line thickness. Good grief. Okay. For every 3 feet we walked in this direction, I had to go 6 feet up. Right? So for every 3 feet forward, I had to go 6 feet up. Right? So that's conveying the idea of how steep the path is that I'm on. Right? Now what we'd like to do is turn this into a number. And the idea that we'll turn this into a number would be to take the ratio of how much we go up divided by how much we go across. And that's exactly what we need to get the slope. The slope is going to be the ratio of how much we go up divided by how much we go across. And sometimes you can simplify these ratios, and so in this case it simplifies to 2. Right? So the idea here is that the slope is the rise divided by the run. The rise being the vertical piece here, and the run being the horizontal piece. Now what's interesting about this is it doesn't matter what 2 points on the line you choose. Right? So when I did it, I chose this point and this point over here, these 2 points. But I could have chosen any other points. I could have chosen this point here and this point here. That would also work. If I look at the run and the rise here, well, the run is just 1 and the rise is 2. And so if I computed it based on that, I would see that the slope was 2 divided by 1, which is still 2. Right? It doesn't make a difference what 2 points I choose on the line to measure this slope. It's a constant for the whole line. And that's what makes it a good descriptor for the line. It's something that's characteristic to that line. Okay, let's go look at another line. Let's go look at a line that's a little bit more of a gentle slope and see what happens. So on this line, let's choose this point over here and this point over here. Okay, so let's see what our rise and run are. So my run is, let's see how many spaces did I go? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 to the right, and I went 2 up. So my rise is 2 and my run is 6. So in this case, let me move out of the way here. My slope is equal to, it would simplify to 1/3, right? So here we have what a gentle slope would look like. Okay, and again, it doesn't matter what 2 points I choose. I could have chosen this point and this point, all right? And if I look at my run and my rise, here my run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And my rise is 1, 2, 3, 4, 5. If I do it that way, I have rise over run. 5 over 15 again simplifies to 1/3. get the same answer, right? Okay, notice I'm using the letter M for slope. That is the traditional letter to use in mathematics, M. Okay, let's go look at another one. Let's go look at this line over here. Here we have a line that's decreasing from left to right. So let's see what's going to happen here. Well, I'll take a couple points on my line. Let's say this one over here and this one over here. And I'll look at, oops, rise and run. Let me fix that a little bit. Okay, so what was my run? Well, it's 1, 2, 3, 4, 5. What was my rise? Well, I had to go down, so that's a -5. So in this case, my slope is going to be my rise over run, -5 over 5. What does that simplify to? -1. So we see that a decreasing line, a line that goes down from left to right, seems to have a negative slope. Let's see if that happens in the next picture as well. See if you can compute the slope of this line. Just pause the video. Try to compute the slope of the line and we'll compare our answers. Okay? So 3, 2, 1. Okay, let's see what we got here. I'll choose this point over here and this point over here, right? So let's see, my rise is this much and my run is this much. So my run is a +2. I moved 2 units to the right. My rise, I went down 1, 2, 3, 4, 5, 6, 7, 8. So -8, right? So if I write rise over run, I'm going to have -8 divided by 2. That's -4. So here we have a slope of -4. And again, it's negative. The line is going down from left to right. Let's see. Let's just back up and take a look at all these from a distance and just see what we can deduce. So we can see that lines that go up from left to right have positive slopes, and lines that go down from left to right. So imagine you're going from left to right. If you're going uphill, the slope is positive. If you're going downhill, the slope is negative. And what about the size of these numbers? The magnitude of these numbers has to do with how steep the line is, right? So these are a couple things that might be worth mentioning. Let me write that over here. For the slope, the magnitude, which is what you would get if you measured the absolute value, correlates to the steepness. Of the line. And the sign of the slope, whether it's plus or minus, has to do with whether it's increasing from left to right, and that would be a positive slope, or decreasing from left to right. And that would have to do with a negative slope, right? So I have a couple other examples. Let's take a look at these. Let's skip that one. Let's save that one for last. Let's take a look at this line. It's a horizontal line, right? So let's see what we'll get here. So I'm just going to take 2 points on the line. Here's a point over here, and let's take another point over here. Okay, so over there. So as I move from one point to another, how many spaces do I go across? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my slope, the run, is going to be 10. What's the rise? How much should I go up in moving from one point to the other one? Well, I didn't go up at all. It's 0. 0 divided by any non-zero number is 0. So this is an example of a line with slope 0. And you can see this is going to happen with any horizontal line, right? So any horizontal line has 0 slope. Any horizontal line has 0 slope. And finally, let's look at this last line over here. Here we have a vertical line. Let's go ahead and pick a couple points. Here's a point down here, and here's a point right there. So go ahead and see what happens when you compute the slope. Pause the video and see what you get. Okay, so 3, 2, 1. Welcome back. Let's see. I know my rise, I went up 1, 2, 3, 4, 5, 6. Or you could say you went down 6, depending on which point you started from and went to. And now what was my run? Well, I didn't go sideways at all, so my run is 0. Now, what is 6 divided by 0? Well, any number divided by 0 is undefined. Undefined. So what we see here is that's going to happen for any vertical line. You're always going to get a run of 0. That's kind of what it means to be vertical. So any vertical line is going to have an undefined slope. Any vertical line has undefined slope. My handwriting is terrible on this this touch screen, but I'm doing the best I can here. So these are some facts, right? So important facts. So vertical lines have undefined slope. Horizontal lines have 0 slope. Well, I also want to look back at some of these things. I want to look at an algebraic formula for computing slope. So we just did everything graphically, right? What if we take a more algebraic approach? Okay, so let's see what we did here. We took 2 points on the line, right? And then we just measured the difference of we measured the rise and divided by the run. Well, how do I get the rise? The rise is the difference of the y coordinates of the points. The run is the difference of the x coordinates of the points. So let's write that down. Okay, the slope, the rise, for the rise, I'm going to take the difference in the y coordinates. So if I call this point up here, let me use a black pen. Well, actually, let's start with the point on the left. Doesn't really matter, but let's do it. x1, y1. I'm going to call that point x1, y1. And I'm going to call this point x2, y2. Okay? So the 6 is the difference between y2 and y1. Right? So the rise is y2 minus y1. And the 3 is the difference between x2 and x1, right? So x2 minus x1. So this is another formula, I meant to write that in red, like my other slopes, is another formula for slope, which is a nice algebraic formula for it. So even if we didn't have a picture, if we happened to know 2 points on the line, we could use this formula to compute the slope. So for instance, this line, I can see that it passes through, if I actually wrote down the coordinates of these points, it passes through the points, this point over here is the point -2, 0. Okay, and then the other point it passes through, this one over here, is the point 1, 6. So even if I didn't have the picture, if all I knew was that it went through these 2 points, I could use the formula that we just wrote down to compute the slope. What would that come out to? Well, we call one of these points our x1, y1, and the other one our x2, y2. Okay? So if I do y2 minus y1, I'm going to take 6 minus 0. Right? That's my y2 minus y1. So it's going to be 6 minus 0. And then I'll do x2 minus x1 in the denominator. So that's 1 minus negative 2. Right? So that's 1 subtract negative 2. And if I compute that out, I get 6 divided by 3, which is exactly the same as what we did up here, by the way. Ends up being the same thing. We get 2. Right? So that's a completely algebraic approach at computing the slope. We don't even need a picture of the line. We just need to know what points it goes through. Okay, let's do another one. Let's go off to the right here. And I'm anticipating this stuff getting in the way, so let me erase that stuff. Let's take these points that we got here. So let's take let's do this point over here. Let's call that my let's just write down the coordinates. Okay, so it's what are the coordinates? 1, 2, 3, 4, 5, 6, 7, 8. It's negative 8, negative 2. That's the coordinates for that point. And the coordinates for this point are 1, 2, 3, 4, 5, 6, 7, 3. Okay, those are the coordinates. So I might be told in the problem, they might just say that the line goes through the points negative 8, negative 2, and 7, 3. Right? They may not even give me a picture, and they may ask me to compute the slope. Okay, so I'm going to label one of these points x1, y1, and I'm going to label the other one x2, y2. So I have point 1, point 2. So when I compute the slope, I'm going to use my formula. Right? It's going to be in the numerator, it's going to be y2 minus y1, so 3 minus negative 2, and in the denominator, it's going to be x2 minus x1, so 7 minus negative 8. So let's see what happens. 3 minus negative 2 is 5. 7 minus negative 8 is 15. Notice that's exactly what we had up here, right? No coincidence there, which simplifies to 1/3. We get the same answer, right? So this is the algebraic approach to computing slopes. Now you might say, well, how do I know which point to make x1, y1 and which point to make x2, y2? It turns out it doesn't matter, right? I could have switched these around, and I invite you to do that. Go ahead on your own. Switch those around. Call the point on the right x1, y1. Call the point on the left x2, y2. Do the same computation. You get exactly the same answer. It doesn't matter. So that's a really great thing about slope. It doesn't even matter what order you put the points in. But what does matter, what is very important is that you have the y's on the top and the x's on the bottom. And you subtract it in the same order in the top and the bottom. So if it's 2 minus 1 on the top, it should be 2 minus 1 on the bottom. Right? If it's y2 minus y1, it should be x2 minus x1. That makes a difference. But what doesn't make a difference is which point you call x1, y1 and which point you call x2, y2. And so as an exercise, you should try it on these other lines over here. Make sure you get the same slope. Go ahead and pick points and use the formulas here. Okay? So I think that's it for this video. I'm going to come back, we'll do a part 2 of this video, and I'm going to talk about a little bit of applications to slope and how we interpret it in the real world. So I'll see you in that video.